Every winter we crank the heat, seal the windows, and still complain about the cold. Now imagine facing temperatures below freezing, with no electricity, no insulation, no steel or glass, and surviving comfortably. Sounds impossible, right? Yet, centuries ago, Native Americans built a shelter so simple that outsiders mocked it as the fool's design. What those outsiders didn't realize was that this so-called foolish idea could outperform some of today's most advanced winter homes. From the outside, it looked too plain to be effective. A dome of earth and grass, barely taller than a man. But inside, the temperature difference could mean life or death. Using nothing but soil, timber, and geometry, these shelters deflected wind, trapped heat, and stayed stable even during the most violent blizzards.
This wasn't luck. It was precision. The rounded shape forced icy winds to flow over instead of against. The thick earthen layers stored heat like a natural battery. Even the doorway placement, low and narrow, kept warmth from escaping. It was engineering at its purest form, functional, efficient, and built entirely from what nature provided. So why call it the fool's shelter? Because it looked too easy to be smart, too natural to be advanced. But the truth? It outsmarted winter itself. Today, modern architects are rediscovering these same design principles, the very ones our ancestors mastered long before blueprints and building codes existed. If you're ready to see how this foolish invention turned out to be one of the smartest survival structures ever built, subscribe now, because every day we bring history back to life.
When early settlers and explorers first saw the dome-shaped shelters scattered across the plains and valleys, they laughed. To them, these rounded mounds of dirt and grass looked crude, even primitive. A fool's design, some called it. Too small, too plain, too fragile to survive the brutal cold of winter. They built their own tall cabins instead, proud of their chimneys and open rooms. But as storms rolled in and the temperatures plunged, it wasn't the cabins that stayed warm. It was the so-called fool's shelters. What outsiders missed was the quiet intelligence behind the design. Every curve, every layer of soil served a purpose. The structure wasn't meant to impress. It was meant to work. Its low, rounded form resisted the wind instead of fighting it. Its earthen shell absorbed daytime heat and released it slowly through the night. Even in deep snow, the shelter stayed anchored, blending perfectly into the landscape it borrowed strength from. Inside, the space was compact and calm. A small fire in the center, a smoke vent above, and a single, low doorway were all that was needed. No wasted space, no wasted heat. Families huddled together in steady warmth, while the wind outside tore at everything else. What seemed foolish to outsiders was actually the result of generations of testing, building, and refining. A design shaped by the land itself. It proved that simplicity wasn't ignorance. It was mastery, hidden in plain sight. Over time, the nickname Fool's Shelter faded, but the irony remained. The most effective solution to surviving a deadly winter was the one that looked the least impressive. The so-called fools had built perfection by keeping it simple. What kept the Fool's Shelter standing wasn't luck or faith, it was physics, learned by observation long before anyone drew a blueprint. The builders didn't fight winter, they made it work for them. First came shape. The dome wasn't an accident. Rounded walls allowed wind to slide across instead of slam into them, creating a calm pocket of air around the structure. That same curve directed heat evenly inside, so no corner stayed cold. Modern engineers would call it aerodynamic design. To its makers, it was just the shape that worked. Next came thermal mass. Thick layers of soil and grass acted like a giant natural battery. During the day, sunlight warmed the outer shell. When night fell, the Earth released that stored heat slowly, keeping the interior steady even as temperatures outside dropped below freezing. Inside, the difference could be dramatic, often 20 or 30 degrees warmer without burning extra fuel. Then there was placement. These shelters were never built at random. They tucked into hillsides, nestled behind tree lines, or faced southeast to catch morning sun and avoid the worst of northern winds. Drainage channels guided meltwater away, while low entrances trapped rising heat inside. Every detail came from careful reading of the landscape, not from written plans, but from years of trial and success. To anyone passing by, it looked like nothing more than a mound of earth. But beneath that simplicity was one of the most efficient passive heating systems ever created. A shelter built entirely by instinct, perfected by need, and strong enough to turn a blizzard into background noise. What made the so-called fool's shelter so effective wasn't expensive tools or rare resources. It was the clever use of what the land already offered. Every material came from the surrounding environment, chosen not for looks but for function. Together, they created an insulation system modern builders would later try to imitate. Soil was the main ingredient, thick, heavy, and full of trapped air pockets that resisted heat loss. Packed over a framework of wood or reeds, it acted like a natural blanket, sealing warmth in and cold out. The denser the soil, the longer it held heat, and once snow covered it, the effect only improved. Snow, often an enemy in winter, became the final insulating layer that locked warmth inside. Wood formed the skeleton. Builders used branches, poles, or driftwood, arranged in a radial pattern, creating a stable dome that can flex under pressure without collapsing. These interlocking frames absorb the weight of soil and snow, distributing it evenly, an engineering principle still used in modern domed structures. Grass, bark, and reeds played the role of insulation and waterproofing. Dried vegetation lined the interior and outer layers, absorbing moisture and creating air gaps that stabilized temperature. Even small details, like layering bark with the grain facing downward, prevented leaks during thaw. The genius was in the combination. Each material supported the others, forming a self-regulating system built entirely from local resources. When you stepped inside, the air felt calm, dry, and still, even as the wind outside screamed across the plains. What looked simple on the surface was actually precision, born from centuries of adaptation. Without nails, cement, or glass, these builders achieved what every modern home still tries to do: comfort, efficiency, and balance with the land. At first glance, the fool's shelter looks like a mound of dirt. No windows, no angles, no sign of design. But the real brilliance was hidden in its geometry. Every curve, opening, and layer worked together to manage air, temperature, and light with precision. It wasn't decoration. It was engineering, disguised as simplicity. The circular shape created balance. In a square or rectangular space, heat pools unevenly, and corners trap cold air. But in a circular dome, warmth circulates naturally, evenly spreading from the central fire pit outward. The roof's gradual slope guided smoke upward, while holding in the lower layers of warmth. A perfect natural convection system that required no vents or chimneys beyond a single, carefully placed opening at the top. That smoke hole wasn't just for ventilation. It was also a regulator. When the wind shifted, it could be partially covered or adjusted, allowing families to control airflow and temperature without losing too much heat. Below, the entrance tunnel stayed intentionally low. Crawling inside forced warm air to stay trapped near the ceiling, while cold air sank harmlessly to the floor by the door. Even the size of the structure mattered. Too large and heat scattered. Too small and airflow stagnated. The average shelter's proportions, roughly half as high as its diameter, created the perfect balance between warmth and breathability. It was designed through intuition, guided by centuries of trial and success.
Step inside during a storm, and the difference was instant. No drafts, no whistling wind, just a steady warmth that felt alive. Not because of technology, but because the builders understood how air moved, how heat rose, and how to make nature's forces work for them, not against them. Each winter tested these shelters the way fire tests steel. Blizzards rolled off the plains like tidal waves of ice, burying cabins and freezing rivers solid. Travelers told stories of nights so cold that wagon wheels cracked and animals froze where they stood. Yet, under mounds of soil and grass, families slept safely, their small fires glowing against walls of packed earth. Historic journals from explorers described their surprise. They would visit a camp expecting to find people shivering, and instead step into warmth. Steam rose from cooking pots, children laughed, and frost never formed on the inner walls. The fools' shelters didn't just survive the storm, they ignored it. When wind speeds reached deadly levels, snow piled over the domes instead of crushing them. The snow's weight sealed gaps, creating an extra insulating layer that turned a liability into protection. Even in blizzards that lasted for days, temperatures inside remained steady. Proof that the design worked, because it used the very forces of winter as allies. Families maintained a simple rhythm. Keep the fire low, tend the vent, block the door with hides to stop drafts. When wood ran short, heat stored in the earthen walls carried them through the night. Outside, the landscape looked lifeless. Inside, life went on. Meals cooked slowly, stories shared, rest uninterrupted. Modern builders still study how these early architects achieved so much with so little. Their shelters were lessons in efficiency, proof that survival never needed to look impressive, only to function flawlessly. In a world obsessed with complexity, these structures stood as reminders that the smartest solutions are often the quietest ones, built from observation, patience, and complete trust in the land. Step inside one of these shelters on a sub-zero night, and the first thing you'd notice wasn't the fire. It was the stillness. The air didn't move, the warmth didn't drift away, and the space felt calm, steady, alive. What kept these homes warm went far beyond flame. It was the way they were built and lived in, together. The design relied on shared heat. Families didn't spread out. They stayed close, their combined body warmth reinforcing what the fire produced. Sleeping flaps mostly slightly higher than the floor, where warm air naturally collected. Beneath them, pits filled with hot stones slowly released stored heat through the night, acting like natural radiators long before the word existed. Even the structure itself worked like a living system. The earthen walls held onto warmth, while hides, furs, and woven mats layered along the interior added another level of insulation. When one family built a shelter near another, the proximity helped deflect wind and stabilize temperature. Entire clusters of homes created small microclimates, warmer, quieter pockets of air that turned hostile terrain into something livable. Daily life inside revolved around cooperation. One person tended the fire, another cooked, others repaired walls or collected fuel. Everyone contributed to maintaining the comfort of the whole. In these moments, the line between engineering and community disappeared. Survival depended not on individual effort, but on design and teamwork working perfectly together. Modern houses depend on technology for climate control. These early shelters achieved it through awareness, precision, and connection. Their secret wasn't just how they trapped heat. It was how they amplified it, through unity, design, and the simple understanding that warmth shared is warmth multiplied. To those who built it, the fool's shelter was more than protection from cold. It represented the connection between people and the ground they lived on.
Its design reflected a belief in staying low, close to the earth, and letting the landscape shape the home rather than forcing it into something unnatural. The rounded shape wasn't chosen for appearance. It echoed the curves of hills, dunes, and riverbanks, the same forms that weathered wind and snow for centuries. Building this way made the shelter feel like part of the terrain, not an obstacle standing against it. When storms came, they passed over instead of through. The home's strength came from humility, from not trying to dominate the environment, only to exist within it. Inside, the space brought people together. There were no rooms, no walls dividing one task from another. Everyone shared the same fire, the same warmth, the same quiet. The design encouraged communication and cooperation, traits just as vital as any engineering feature. The materials themselves reinforced this unity. Earth, wood, and grass all blended seamlessly. When the shelter eventually wore down, its remains returned naturally to the soil. There was no waste, no trace of destruction, only renewal. Each structure was both a shelter and a statement. Survival didn't require separation from the world, but alignment with it. Its builders didn't carve the land into submission. They shaped their homes to flow with its patterns. In a landscape that could be deadly in minutes, this simple philosophy turned fragility into strength. The Fool's Shelter wasn't just built on the land, it belonged to it, proving that the smartest designs are often the ones humble enough to disappear back into the world that made them possible. Centuries later, architects and environmental designers are finally catching up to what early native builders already understood: that efficiency begins with listening to the environment. What we now call green architecture was standard practice for people who had no blueprints, no insulation factories, and no electricity. Modern studies have confirmed that these dome-shaped earthen shelters achieved remarkable energy stability. Their rounded geometry minimized heat loss and structural stress, the same principle used in modern geodesic homes. The thick earthen walls functioned like passive solar systems, storing warmth from sunlight during the day and releasing it slowly through the night. That same idea now drives the design of eco-homes, thermal mass buildings, and earth-sheltered architecture across the world. Even ventilation in the Fool's Shelter mirrors modern engineering. Controlled airflow through low entrances and top vents created natural convection cycles that maintained air quality without losing significant heat, a system now replicated in passive houses and energy-efficient domes. And materials. Builders today are rediscovering what those early communities knew instinctively: that local resources outperform imported ones. Earth, clay, and vegetation have lower environmental impact, cost less energy to produce, and naturally regulate temperature. The so-called primitive designs were, in truth, models of sustainability. What makes this connection even more powerful is that their success didn't rely on technology, only awareness and balance. They built what worked, refined it through observation, and left a design so efficient it still inspires innovation centuries later. The irony is hard to ignore. What early settlers dismissed as backward now sits at the heart of modern sustainability. The Fool's Shelter wasn't a relic, it was a prototype, a quiet lesson in how to build smarter by keeping things simple. The Fool's Shelter earned its name not because it failed, but because those who first saw it failed to understand it. To outside eyes, it looked primitive, too small, too rough, too close to the dirt. Settlers and explorers were used to tall walls, square corners, and chimneys that announced progress. A mound of earth didn't look like civilization to them, but what they mistook for ignorance was actually refined engineering, hidden behind modesty. The builders of these shelters didn't write about their work. They built it, tested it, and passed it down. Their knowledge came from observation, not theory. They learned how wind curved around hills, how sunlight entered narrow openings, how soil trapped heat better than timber. Each design was the result of countless small discoveries that turned necessity into precision. The misunderstanding came from pride. Outsiders assumed that simplicity meant inferiority, that true intelligence required complexity. Yet the shelters they mocked lasted longer, required less maintenance, and kept people warmer with almost no resources. Over time, as winters claimed more uninsulated cabins and settlers struggled to adapt, the Fool's Shelter quietly proved its worth. Its builders had solved the equation of comfort without excess, something the modern world still struggles with. Calling it foolish was easier than admitting they had something to learn. But history has a way of reversing judgments. Today, as energy-efficient homes and earth domes gain popularity, that same design, once dismissed as naive, is finally being recognized for what it always was: innovation born from observation. The so-called fools were, in truth, the first engineers of resilience. People who turned minimal materials and maximum understanding into a design that could stand against one of nature's toughest tests: winter itself. The genius of the so-called Fool's Shelter didn't fade with time. It just waited to be noticed again. As modern winters grow harsher and energy costs climb, the same questions those early builders answered centuries ago are resurfacing. How do we stay warm without waste? How do we build strong without harming the land? Their solution was simple: use what's around you, understand how the environment behaves, and design with it, not against it. The rounded shape, earthen layers, and compact interiors weren't primitive choices. They were refined responses to real conditions. No concrete, no electricity, no complex machinery. Just observation, patience, and practical problem-solving. Architects today are taking another look. Earth-sheltered homes, passive heating designs, and self-regulating structures all draw from the same core idea: efficiency through cooperation with nature. What was once dismissed as foolish has become a foundation for sustainable architecture in a world finally realizing that complexity isn't the same as intelligence. The deeper lesson is humility. The builders of these shelters didn't try to conquer the cold. They learned how to live through it. They didn't build monuments. They built solutions. And in doing so, they created a design that remains relevant in every era that faces scarcity and climate challenge. As the planet grows colder in some regions and hotter in others, the old answers might be the best ones we have left. The Fool's Shelter stands as a quiet reminder. True progress isn't always about building higher. Sometimes it's about building smarter, closer to the earth, and in harmony with the world that sustains us. As the snow settles and the cold wind fades into silence, one truth stands clear. The shelter once dismissed as foolish turned out to be a masterpiece of survival. It didn't need steel, concrete, or blueprints to prove its worth. All it needed was a clear understanding of how to work with the land, not against it. Every curve, every handful of packed soil, every layer of grass was there for a reason. What looked like a mound of dirt to some was, in reality, a structure fine-tuned by centuries of testing. It didn't just resist winter, it absorbed it, redirected it, and turned it into warmth. Modern builders spend fortunes chasing efficiency, yet the answer has been under our feet all along. The Fool's Shelter didn't waste energy, didn't scar the landscape, and didn't need constant maintenance. It succeeded because it respected the balance between design and environment, something our technology-driven world often forgets. Its builders didn't seek recognition or praise. They simply built what worked, quietly, effectively, and beautifully. And that's the irony. The people once thought to know the least actually knew the most. Today, as we face colder winters and a more unpredictable planet, the lessons still stand. Strength doesn't always look sophisticated. Intelligence doesn't always shine in complexity. Sometimes it hides in plain sight. In a curve of earth, a layer of grass, a shelter so simple it outlasted arrogance itself. If stories like this change the way you see the past, and maybe even the future, subscribe now. Because every day we bring history back to life, not as myths, but as proof that the smartest ideas are often the simplest ones waiting to be remembered.